I'm Dana Shagru with CE Ag World Greenhouse Produce, an innovative brand that engages with the rapidly expanding global greenhouse produce industry through a variety of platforms. Our mission is to educate and connect greenhouse produce growers and industry allies to help them better understand and sustainably advance the global food industry. On this episode of CE Ag Talks, I'll be speaking with Dr. Tom Fernandez, a professor in the Department of Horticulture at Michigan State University. Tom, welcome to CE Ag Talks.
Hi, Dana. Thank you. It's nice to be here.
Today, we'll be talking about how to effectively treat water after it's used to irrigate plants in greenhouses. So, to begin, Tom, can you tell us a little bit about your 25-year career at MSU?
Yes, I started back in 1999, so right before the turn of the century. Who'd ever think you'd say words like that? And then when I first started at MSU, I wanted to look at how pesticides moved in, and I primarily work with nursery production, but I do also work a little bit with greenhouse production and specifically on water quality and water management issues. And so at the time, we wanted to look at how pesticides move through container production systems. And at that time, we were focusing mainly on outdoor nursery production. And so we started looking at irrigation methods, how we could modify irrigation or conserve irrigation water to reduce the amount of water that was running off operations. And that's the primary method of movement for agrochemicals. And by that, I mean fertilizers and pesticides and other things, growth regulators, those types of chemicals. And so we started looking at different ways of scheduling irrigation so that we were basically replacing the amount of water that the plant was using within a 1-day period the next day. And what that ended up doing was reducing the amount of water that we were applying up to 80%. And that depended on the plant species, right? So there's some plants that use water more heavily than other plants. And so we had a range of reduction between around 30 to 80% in the amount of water that we were applying to the plants. And that resulted in a very similar reduction in the amount of runoff that was leaving the production area. And of course, if you think about, and this was overhead irrigation. So if you think about any type of overhead irrigation, whether it's sprinklers or booms or any type that's coming over the entire production surface, a lot of times that's exactly where you apply your agrochemicals as well. You're applying them as a spray or sometimes as a granular that you're spreading across that entire production surface. So you're not just hitting the target, the container substrate, but you're also hitting those non-target areas, the ground cover that you're growing your plants on. Irrigation coming through overhead systems also hitting the entire production area, and it's moving agrochemicals from those non-target areas as well as leaching them through the containers and out through the leachate. So we wanted to look at reducing how much water we applied so that we reduce the amount of runoff generated, which would reduce the amount of agrochemicals moved as well. And we, again, quite a huge reduction in agrochemical movement. And we looked at a range of chemicals. So fertilizers move very easily, most fertilizers, because they're designed to enter the plant that way, right? They're salts. And then we have a range of pesticides that we looked at, from some that were very slow moving to others that were more rapid moving. And we would find, depending on how we irrigated, usually we reduced the slow moving ones almost to no movement at all. And then the more rapid ones move more like nutrients. The less runoff that we generated, the less pesticide moved through the system as well. So we've kind of combined looking at ways to conserve water, reduce irrigation applied, reduce runoff generated, which reduced also nutrients and pesticides moving in water. So that's been the main focus of where I have been doing research. And then what we've started doing about 6-7 years ago now is looking at ways to reduce the chemicals in the runoff from leaving the site or from being reintroduced to the crop if the water is recycled for irrigation. And we're using bioreactors to investigate that.
Yes, we'll get into the bioreactors later in the conversation because I know that's an exciting new project you're working on. But just to give our audience a little bit of background, can you explain why it's especially easy to overwater plants in greenhouses?
Right. Well, I think part of it is kind of psychological, right? We all see what happens when a plant in a pot dries out. The substrate shrinks off the container wall. It becomes very difficult to re-wet. The plant starts wilting, may even reach permanent wilting and die. And so it's very obvious what happens when a plant gets overwatered, underwatered rather. And so we want to avoid that. And one of the ways to do that is to make sure that you get more than enough water to the plant. The problem is a lot of times it's not understood or not realized the negatives of overwatering plants, right? You can make a plant more vigorous, which a lot of times makes it more susceptible to disease and insect pressures. You can leach out fertilizers, which can lead to nutrient deficiencies, plus the negative environmental aspects and the waste of money of leaching out fertilizers. You can cause more disease issues just from the water being there, and more weeds and associated pests. Like I think a lot of greenhouse growers have issues with liverwort, one of the worst weeds in a greenhouse system, and that can be exacerbated by excess water. So all of those things are what we don't think about because we can so easily visualize a plant drying up and desiccating, right? So we want to avoid that, and that's understandable. The other thing is we have a very small volume of substrate to retain the water that we need for that plant for however long it is between our irrigation period. And so they're also designed to drain fairly quickly. So those two things, a small volume and quick drainage, leads to the substrate drying out fairly rapidly. And so we're watering a lot more frequently than a person growing out in soil ever would think about doing. And so that can tend to build on that overwatering pressure.
Thank you for answering that. I think it helps give a little bit of background. And you're right, it is much easier to visualize a plant drying out than being overwatered. I feel like a lot of people think that's the lesser of two evils.
Right, exactly. But they can both be equally as bad.
So you talked about this a little bit in your intro. Like, can you tell us more about the new project you're working on that focuses on treating water used in greenhouse production? And I know you mentioned the bioreactors, but I would love for you to talk about that as well.
Okay. So a bioreactor, it's just a fancy name for a bunch of wood chips that we run the production water through. So that the return water from whatever type of irrigation system you're using, if you're recapturing water or if you're directing it to a particular spot where you can run it through these wood chips, that the wood chips are a bioreactor, right? And what the wood chips do is provide a home and food for a bunch of microorganisms. And some of those microorganisms will actually they all use nutrients. They need the same nutrients as plants. So they'll use the nutrients that are in the water, but they'll also use they'll use most of the pesticides. Most of our pesticides are made of carbon, hydrogen, oxygen, and then some other chemicals. Then the microbes will use that as a food source as well. And so what they will do is they'll start feeding on the pesticides and breaking them down to non-toxic compounds. They're also using the wood chips, right? The wood chips also serve as a food source for the microbes as well. So what we've done is we've done a couple lab-based projects where we're using small, they're like totes, right? These totes used to store stuff home. We fill them up with wood chips, and then we create a simulated runoff with nitrate, phosphate, and then we've used some pesticides in them as well to see how those bioreactors will reduce all of those compounds.
Can you explain how you can get greenhouse growers to start using bioreactors more in their operations?
Yeah, so I think one of the main ways is that we're working with one of the larger, well-respected growers, not only in Michigan, but around the country. And so once they're comfortable with us sharing who they are, I think that will, you get the industry leaders involved, and that brings along other people. They say if this company is doing it and they see it as being successful and improving their production, it's something we should consider.
Well, Tom, thank you for taking some time out of your morning to speak with me about your research and your career at MSU. Is there anything else you think is important to mention or that our viewers should hear about?
No, happy to share what we've been doing. I know I've missed some things that we've been doing, but I think you have a lot of information. Hopefully, not too much. But it was been a pleasure and fun to talk with you.
Yeah, great to meet you, Tom. I'm sure we'll talk again soon.
Okay, sounds good.